Okay, now we're going to try some subtraction. Let's do number 6. Square root of 3/4 minus 1/3 times the square root of 3. Okay, so first things first, let's get that radical out of the bottom. I'm just going to squeeze. Let me just scoot everything over so that you can still see. Okay, I left myself a space in here because I know I'm going to have to go in and do surgery on that 4. Wow, how dumb is that? I don't need to do surgery on that 4. That 4 can come straight out and be a whole 2. So the square root of 3 over 2. Here we go. Minus 1/3 times the square root of 3. We've really got, let me write this again the way we were practicing writing our answers for those earlier sections. 1/2 times the square root of 3. So there's a 1 up here. 1 over 2 times the square root of 3. 3 is still in the numerator. We're just writing it to the side, kind of like we would an x or a y. 1/3 times the square root of 3. Now, see the way that's written? Doesn't that make it clear to you? They are attached to the same radical, so yeah, we could add them. The only thing is they need to have the same denominator. So let's do that real quick. Just multiply by 1 to both fractions to get them to 6 is going to be the best choice. Denominator of 6, so 2 over 2. Won't change our fraction, it will just get it to have a denominator of 6. 3 over 3, same thing. Same idea to this side. Okay, so 3 times 1 is 3. 3 times 2 is 6. 3/6 times the square root of 3 minus 2/6 times the square root of 3. Now we'll just add our coefficients, if you want to call them that. And so 3 minus 2 is 1. 1/6 times the square root of 3. There's your answer. All right, let's do one more. Let's do number 9. I'm going to do number 9 right here. Okay. We've got 2 times, scoot 9 over so we do not confuse it with being in our problem. Okay, we've got 2 times the 4th root of 36 minus 3 times the square root of 3 over 2. 2 different indexes, keep that in mind. So 2 times the 4th root of 36. 4th roots, let's think of some 4th roots, how we could take care of this. Well, one way to look at it might be, instead of bringing this one up to be a 4th root, you could bring this one down to be a square root. Remember some of the reducing we were doing, we just take it out of its radical. So call it 36 to the 1/4 minus 3 times 3 over square root of 2. While I'm at it for this step, I'm actually going to go ahead and write that multiplication in to get my 2 off the bottom. And then over back to this step, I'm going to keep working. 2 times, 36 is 6 squared. So I'm going to write 6 squared and then still write that 1/4. That way I'd really not changed anything. I just wrote 36 as 6 squared. It's same number. Minus 3 times square root of 6 over just a regular 2 now. Square root of 2 times square root of 2 is regular 2. So now I'm going to keep writing down 2 times, now do your math. 6 squared is just like saying 6 to the 2 over 1. So multiply these exponents. 2 times 1 is 2 times 1 is 2. 1 times 4 is 4. 6 to the 2/4. Oh, that'll reduce down nicely to 1/2. And then 1/2, what does that tell you about the kind of radical you get to put 6 under? It will match this 6 over here. Minus 3 over 2 times the square root of 6. All right, let's get down to business here. 2 times the square root of 6 minus 3/2 times the square root of 6. We're almost there. Now our fractions out here, our coefficients, they need to match in terms of denominator so that we can go ahead and subtract and get this problem done. So this one right now has a denominator of 1. So let's just multiply top and bottom by 2. Just like that. So 2 times 2 is 4. 2 times 1 is 2. 4/2 times the square root of 6 minus 3/2 times the square root of 6. Well, you just 4 minus 3, that's 1, equals 1/2 times the square root of 6. And there we've just subtracted some radicals. That's not so bad. Okay, we are doing adding some radicals in section 8.6. In order to add them, they're going to need to have the same index, the same order, which is they all do have a cubed index. Let me fix this one right here. But our radicals are not the same. This one's 1/4, this one's 54/16. We can't put them together unless the radicals match. So let's first off start by getting this 4 that is on the in the denominator, getting it to be not having any radicals on the bottom. Anything under a cubed root, if you want to get it out of there, you need to find a way to get it cubed. So I'm going to multiply a cubed root of, let's look at this. 4 is really, we could simplify that down to say 2 squared. That way we don't have to multiply it by so much. If you've got 2 squared, all you're going to need now is just one more cubed root of 2 to get cubed root of 2 cubed. So I'm going to say cubed root of 2 over 2. That's 2 to the 1. That'll get us what we need. So let's work on these others too as we bring down other steps. Cubed root of 16. Okay, dealing with cubes, we want to simplify it down. What is a cubed, perfect cube that is in 16 maybe? I know 16 is not, but it's made up of 8 and 2. Okay, let's bring down our other bit of work. Let's do the math right here. 1 times 2 is cubed root of 2. And the 2 squared times 2 is 2 cubed. That will come out in the next step. We'll take that out. Okay, and we have the cubed root of 54. Let's break our 54 up just a little bit. 54 is, well, I know it's 9 times 6, but neither of those is a cubed root. I'd like to get it cubed. Is 27. Can 27 go into 54? I'm going to add these two together real quick. 14, yes. 27 times 2. That's what's in 54. That'll get us a cube to come out. So let's take cube root of 8, like we planned on doing. Leave the cube root of 2 under there because it will not come out. Plus 2 times the cube root of 2 over just a whole 2, because 2 cubed, the cube root of it, well, 2 cubed is 8. Cube root of 8 is 2. There you go. Plus cube root of 27, that is 3, times cube root of 2. So now we're getting all cube roots of 2. Look how that works out. I mean, they're going to give you problems that will work out. So if something is just looking very wrong, you probably missed a number or an exponent or a sign or something somewhere. So they know how these problems will turn out. 2 times the cube root of 2 plus 1 times the cube root of 2. I don't have to write the 1. Plus 3 times the cube root of 2. That's going to be 2 plus 1 is 3. Plus another 3 is 6. So our answer is, I'll just write it over here, 6 times the cubed root of 2. There you go. All right, let's do number 14. We have 10 times 1/5, square root of 1/5, plus square root of 80, plus 6th root of 125. All right, first let's try to get this 5 out of here. So I'm going to scoot that. Was it a plus sign? Yes, it was. Okay, I'm going to scoot that plus sign over. And let's multiply top and bottom by square root of 5. That way we'll have square root of 25. 10 times the square root of 5 at the top, square root of 25 at the bottom, plus the square root of 80. All right, it's looking like square root of 5 may just be our lucky radical for this problem. So let's see if there's what 5 can go into 80. Because you're going to start seeing patterns, you know, they generally make it so that your radicals you'll be able to find similar ones to make the problem work. So 80 divided by 5. 1 times 5 is 5. 3, 0, okay. 6 times 5 is 30. All right, so 16 times 5. Oh, that's a perfect square. So 16 times 5 plus the 6th root of 125. Well, 125, if you've done a few 5 problems they've had in here, is a very special number. It is 5 times 5, that makes 25. 25 times 5, that makes 125. So all 3 of those make 125. So I'm going to write this as a fractional exponent. Watch this. 5 cubed to the 1/6. The 1/6 comes from it being like, maybe I skipped too many steps for you just in case that bothered you. I'm going to write it like this. Show you both steps. First I take the 125 and write it with a 1/6 exponent because it was to the 1 in here, and the 6 becomes the denominator for a fractional exponent. We take away the radical sign. Then we say 5 cubed, since that's the same thing as 125, and then we say that to the 1/6. So now when we multiply it out, we multiply that 3, that cubed, which is really 3 over 1. We multiply it, 3 times 1 is 3, 1 times 6 is 6. We are going to get 5 to the 3/6. And we all know 3/6 is just 1/2. Reduce down. And look, 1/2, square root, that's what we got all in this problem. So this is perfect. All right, 10 times the square root of 5 over a whole 5 plus square root of 16 is 4 times the square root of 5 stays under, plus 5 to the 1/2. And that goes under the square root like this. So now our 10 over 5, well 5 can go into 5 one time, into 10 2 times. So that's 2 times the square root of 5 plus 4 and 1, that's going to be 5 times the square root of 5. Then we just add the 2 and the 5, 7. 2 square roots of 5 and 5 square roots of 5, if you drew them all out, 1, 2, 3, 4, 5, 6, 7. Square roots of 5. There's your answer. All right, let's do number 16. Flip page. Number 16. Make sure you can see that in there. Yes. Okay. Cubed root of 8 over 5 plus the cubed root of... Let me give myself more room, because I have a feeling we're going to have to be doing some surgery on some of these. Cubed root of 1 over 5 plus the cubed root of 27 over 5. All right, they're all cubed roots. They're all over 5. Interesting. All right, let's do... Let's go ahead and try to get our 5s out. So I want my 5 to be cubed. Right now it's just at the 1, at 5 to the 1. So I'm going to multiply top and bottom by 5 squared over 5 squared. And of course it's a cubed root of 5 squared over 5 squared. Cubed root of 5 squared over 5 squared. Cubed root of 5 squared over 5 squared. Now, multiplying top and bottom by the same thing so I don't really change anything. All right, let's carry this down. And our math looks like this. Cubed root of 8 times 5 squared is 8 times 25. I'm not going to worry about working it out yet. 5 times 5 squared is just 5 cubed. Plus 1 times 5 squared is just 25 over 5 times 5, 5 cubed. Oop, don't forget my index. Plus, okay, we got 27 times 25, over 5 times 5 squared, that's 5 cubed. I'm starting to see a way I could have done this that wouldn't have made such big numbers. But let's see if we can finish it out like this. All right. Take 5 out. So we got cubed root of 8 times 25 plus cubed root of 25. I'm just getting all my tops written out. Plus, oh, I forgot the index there. Cubed root of 27 times 25. Well, I can just take my cubed roots out now. I was thinking my idea was I could have maybe taken some of them out earlier. But it's fine. It's just the way I'm doing it. They're all over 5 cubed, so I'm just going to write it, or all over 5. So now let's work on taking out my 8. Cube root of 8 is just 2. 2 times the cubed root of 25 plus just the cubed root of 25. Oh, cool, maybe. Hey, this is just going to be our similar radical. Plus, you've probably saw that before I did. I was sitting here worried. Cubed root of 27 is 3. And then that 25 stays in and we're ready to add. But don't forget, they're all over 5. And we can write it like that. When they share a denominator, you might as well go ahead and put them over it. So 2 plus 1 is 3. Plus 3 is 6. Answer is 6 times the cubed root of 25. Actually, I'll write it the way Abeka likes it, which is 6 over 5. Like that, with the cubed root over here. Here you go. Let's do number 26. I've written, this one is easy, so I wrote that last year. Let's see if it's still easy. A over x squared plus a over y squared, of course these are under square roots, minus square root of a over z squared. Well, they are squared in a square root. They should just come right out. So let's do square root of a over x plus square root of a over y minus square root of a over z. Now, if I need a denominator that will work on all of them, I've got a different letter under each one. So really, they would all have to be represented in a denominator kind of like this, or just like this. So, so for my x, y, z is what we're trying to get at the bottom. For my x, I will need a y and a z. So I'll multiply yz over yz, which just means 1. And for my y, oh, I forgot the sign. Okay. So for my y, I will need an xz over xz. For my z, I'm just lacking the yx. Yx over yx. Now I'll just do the math. Yz times the square root of a over xyz plus xz times the square root of a over xyz minus square root of a, or I'm writing my square roots of a last, so I'll do that here too. Yx times the square root of a. Make sure you can see that. Over xyz. So now they're all over xyz. I might as well have written that one time, but oh well. Now, what I could do, each one of them has a square root of a right there. Maybe what I'll do is just put my square root of a, well, not on the front end, but on the tail end, since Abeka seems to like to scoot the radicals out to the right side. Square root of a right there. Basically, I'm just factoring it out, and I'll write all the other pieces. Yz plus xz minus yx, all being multiplied times square root of a. If you multiplied it back out, you'd be back to here. yza, xz, a square root of a minus, yx square root of a. You'd be back out to there. All over x, y, z. It's a very lettered answer, but that is it. All right, let's do number 27, and then we can be done. Number 27. Square root of a plus b squared times c, all under that square root, minus the square root of a minus b squared times c. Interesting. Okay. Well, anything squared under a square root just comes out. So I'm going to take my a plus b, and it'll come out not to be a squared, but just to be a plus b times the square root of c, minus a minus b can come out, a minus b. And really, I should keep it in its parentheses so that you know I want a plus b, the whole thing, multiplied by c, not just the b. So keep that parenthesis. Minus a minus b times the square root of c. Interesting. So they're both being multiplied times the square root of c. This feels like some kind of weird factoring thing going on here that Abeka wants to confuse me with. A plus b minus a minus b all times c. So they're both being multiplied by c. I'm going to take it out of there and put the c. I'm going to put it on the front for now. Square root of c is being multiplied to a plus b minus a minus b. Okay. Now that I got that laid out, I'm going to work on the inside a little bit. Square root of c. Just think of it, pretend a plus b was x and a minus b was y. You're just saying x square root of c minus y square root of c. So we decide to say square root of c times x minus y. It's a way not to have to write square root of c twice. Okay, so moving on, I'm going to do some math in here. I'm going to take everything out of the parentheses, but when you have a minus in front of a parentheses, you have to give that minus to the a and the minus to the b. So it's going to change their signs. It's like there's a -1 here. That's why you do it. -1 times a, -1 times b. So we have a plus b minus a, got the -1 to the a, and then when it goes to the b, it really makes it positive b. So we are a little simpler because we've got a positive a and a negative a. Those are going to make 0. I don't care what number they are. And then square root of c times positive b and positive b, that's 2b. Okay, so our final good way to write it would be the radical last, 2b times the square root of c. That's interesting. And that's it for 8.6.